Lesson 4 was all about solving rational equations after we created them from word problems. So before we get into this, let's make sure we can actually solve a rational equation by getting a common denominator on both sides. So it looks like everyone needs a t minus 3, a factor of 2, and when I see that t squared minus 9, I'm thinking t minus 3, t plus 3, because it's the difference of squares. So everyone needs all three of those pieces. Everyone needs a 2, a t minus 3, and a t plus 3. So it appears that this first term is missing the 2 in the denominator and the t plus 3. The middle term has the 2, but it's missing the t minus 3, t plus 3. I'm going to write that as t squared minus 9. That's the t plus 3, t minus 3 right there. Equals 12 over t squared minus 9. Well, that's just missing the 2 because it's got both of those linear factors there, so it's missing the 2. So I'm left with 8 times t plus 3 plus t times t squared minus 9 equals 24. That tells me 8t plus 24 plus t cubed minus 9t equals 24. If I was to write this in standard form, I'd have t cubed minus t plus 24 equals 24. Well, it's a polynomial equation, so I should set it equal to 0. If I subtract 24 from both sides, I nicely end up with t cubed minus t, those add to 0 as well, equals 0. Be careful, this is not the difference of perfect cubes. The first term's a perfect cube, but that is not a perfect cube, so let's factor out a t, and I'm left with t squared minus 1 equals 0. If I was to continue factoring that, that'd be t times t plus 1, t minus 1 equals 0. And now using the zero product property, I get t equals 0, t equals negative 1, and t equals positive 1. So my solutions are 0 and plus or minus 1. But I can't box those in yet and say I'm done yet until I go and check. Well, what values would I have to throw out? Well, what would make that 0? T cannot equal 3, because 3 minus 3 would give me 0. So we throw out 3. That's always 2. That's never going to be 0. And I also have to throw out negative 3. T cannot be negative 3. So our solutions are 0 and plus or minus 1. There are no extraneous solutions here. Huck can paint a fence in 5 hours. And working with Tom, the two of them painted a fence in 2 hours. How long would it have taken Tom to paint the fence alone? So if Huck can paint the fence in 5 hours, in 1 hour he can paint 1/5 of the fence. So in 1 hour, he'll do 1/5 of the fence. We don't know how fast Tom is working, so in 1 hour, he'll do 1 over x, because I don't know how many hours it takes Tom. But together, when I add those together, they can get half the fence done in an hour, because they get it done in 2 hours. So everyone needs a 5, an x, and a 2, so everyone needs a 10x. So this first term is missing a 2x. This next term is just missing 10, and this last term is missing 5x. So I get 2x plus 10 equals 5x. So 10 equals 3x. So x equals 10/3. So it takes him 10/3 hours to paint the fence. Well, what does that actually mean? Well, that's 3 1/3, so 3 hours. And what's a third of an hour? 20 minutes. So it takes Tom 3 hours and 20 minutes to paint a fence by himself. 3. The difference in the average speed of two trains is 16 miles per hour. So I'm going to subtract two things here, and I'm going to get 16 miles an hour. So remember, distance equals rate times time. So I'm talking about the rates here, so distance over time equals rates. The slower train takes 2 hours longer to travel 170 miles than the faster train that takes 150 miles. Find the speed of the slower train. So, if I have 150 miles over time, distance over time, minus 170, it's that same time but 2 hours longer. That should give me 16. So I have this rational equation here because I have these variables in the denominator where everyone needs a t and a t plus 2. So that first term is missing a t plus 2. This next term is missing a t. And the 16 is missing both the t and the t plus 2. But now since my denominators are the same, all I care about is the numerator. 150t plus 2 minus 170t equals 16t times t plus 2. Well, now I just need to solve this equation. 150t plus 300 minus 170t equals 16t squared plus 32t. Well, it's a quadratic, so I should set it equal to 0 after I clean it up a bit. 300 minus 20t equals 16t squared plus 32t. Well, I'm going to subtract the 300 and add the 20t to end up with 0 equals 16t squared plus 52t minus 300. Well, now we have to factor this quadratic because I set it equal to 0 and now I have to factor. It looks like there's a GCF. Well, I think I can divide everyone by 4. So if I take out a 4, I'm left with 4t squared plus 13t minus 75, because otherwise the AC method would be ridiculous there, equals 0. And now I need to ask myself, what multiplies to 75 times 4? What multiplies to 300? 4 times 75, well, negative 300. That adds to 13. What two numbers multiply to 300, negative 300, that add to 13? Well, they need to be relatively close to each other because I want them to add to 13. So take a second, try dividing things. They should be pretty close to each other, so maybe it's 10 and 30. No. Maybe it's 15 and 20. No. 12 and 25 seems to work. 12 and 25. But I want a positive 13, so I need a negative 12. So now I can split up that middle man as 4t squared minus 12t plus 25t minus 75. Now we can group, take out a 4t from the first two, and I'm left with t minus 3 plus 25 times t minus 3. So I'm left with 0 equals my new factor is t minus 3, and I'm left with 4t plus 25. Now the GCF of 4 doesn't really matter because that 4 never gives me 0, because my solutions come out to be t equals 3 or t equals negative 25 over 4. But I can't have negative 25 over 4 because I'm talking about the time the train travels for, and it's not going to be negative. So our solution has to be, it takes 3 hours. T equals 3 is our solution. Let's just make sure we didn't divide by 0. No, we're good here. So find the speed of the slower train. Well, careful here. T equals 3. That was the faster train. So faster is 3 hours, and the slower is t plus 2, so 3 plus 2. So the speed, well, the slower is 170 divided by 5. 170 divided by 5 comes out to be 34. 34 miles per hour is the speed of the slower train. The speed of the faster train is 150 divided by 3 is 50 miles per hour. Is that difference 16? It is. 50 minus 34 is 16.